Hi everyone, and welcome to the last part of Activity 32. Today we are going to talk about the polar form of our complex numbers. So our rectangular form we chatted about yesterday, and that's going to be a plus bi as our rectangular form. The polar form is going to write this with our r value on the outside and then our theta value on the inside with cosine plus I sine. Sometimes we write that in a shorter version. We call that cis notation. So again, the r is standing for our radius, and we see that, again, kind of acting as that length here on our vector, and you find that r value by taking the square root of a squared plus b squared to find that r value. The theta value then is going to be found by taking tan inverse of b over a, and then again being very cautious with that of making sure you are in the correct quadrant, because theta really is representing quadrant 1 versus finding our quadrant 2 or 3 or 4 value. We also want to take special consideration in case we are on an axis what we would be pointing to towards our theta, because we've talked a lot about our calculators and how they may or may not represent that. So graphing it or thinking about where it would be pointing is often very helpful. For this first example, we have 6 plus 8i. So our vector would be going to the right 1, 2, 3, 4, 5, 6, and then up 2, 3, 4, 5, 6, 7, 8, and we'd be pointing there in quadrant 1. So when we're looking for that r value, we'd be taking the square root of 6 squared plus 8 squared, which ends up being the square root of 100 or 10. Our theta value this time, if we take tan inverse of b over a, we end up with 53.1. Now again, this angle is okay for our theta because again, theta this time is in quadrant 1, 53.1 would work out. So we're either going to write this as 10 on the outside cos theta plus I sine theta, or you're going to see this represented in cis notation where you write the r, cis, and then the 53.1. So standing for cosine I sine with that cis notation. In our second example, we are going to the right 5 and then down 12. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. This time we're moving into the fourth quadrant. So as we start looking for these, we have the square root of 5 squared plus negative 12 squared. So that's 169. The square root of that then is 13. And our theta value will be found by taking tan inverse of negative 12 over 5, which, tan inverse of negative 12 over 5 is about negative 67.4. Now we know again that this needs to be a quadrant 4 value. So officially that could work out that negative 67.4. Sometimes you're going to see though that we like to write this between 0 and 360. Officially both should work. But again, 360 minus theta would give us 292.6 as our value there. We can use as our theta. So again, you either can write it, you might need to write it long form where we plug in our r and then cosine theta plus I sine theta. Or you might see that represented with cis notation, cosine I sine the 292.6. Right. Now, sometimes they are going to ask us to convert this back to rectangular form. So what I always like to think about this as is it's almost like you're distributing this back through. We have 6 times the cosine of 60, which is 1/2. And then we have 6 times the sine of 60, which is square root of 3 over 2. So that's going to be 3 plus I and then 6 divided by 2 is 3, root 3. Or if you want to think about it in the form of decimals, this would end up being 5.2i. So we kind of know what we're moving right and or left each time. So for this one, again, you're going to the right 3 and then up 5.2. So we see another quadrant 1 value for this one. Second one, if we distribute this through, 2 square root 2 times the cosine of 225, which is negative root 2 over 2, plus I times 2 root 2 times the sine, which is also negative root 2 over 2. The 2 here and the 2 here will cancel. Negative root 2 times positive root 2 is just negative 2. And then these will cancel also. And square root of 2 times negative root 2 is going to actually be a negative 2i. And so this time we're going to the left 2 and down 2 for our vector when we graph it. All right, last page is going to talk about some of our shortcuts here when it comes to multiplying vectors in their polar forms. And basically what ends up happening on these is that we are allowed to kind of shortcut that if you are multiplying these vectors, what ends up happening is you are multiplying their r values, and then you would add their theta values together, so that would be the value on the inside. So if we look at some of these examples, for the first one, if we want to find the complex form, to get the r value, we are going to take the r values from the originals, 10 and 3, and we are going to multiply them together so that we would get 30. To get our theta value, we're going to take the theta values from the original, and we're going to add them together. So 45 plus 30 is 75. So when we write our final answer, that r value we just found on the outside, and then cosine 75 plus I sine 75. Or again, you might see it represented in cis notation. For the second example, again, if we are looking for our r value, we are going to take the r values of the original 2 and multiply them. So 5 times 2 is 10. To find our theta value, we're going to take the theta values from the original and add them. So 150 plus 240 for a total of 390. And our final answer then, you would have 10 cosine of 390 plus I sine 390, or 10 cis 390. Now, side note here, you may want your answer between 0 and 360 only. So maybe you found the coterminal to this and only used 30 degrees. That also could work because, again, they are coterminal to each other. So if in this we chose to just do the coterminal value of 30, these are again in the same location. That could work as well. Now, if we're raising this to more than just like multiplying 2 together, let's say we're multiplying, we're raising to the third power, essentially what's going to end up happening is to find the r value, we're going to take the r value from the original and basically end up multiplying it by itself 3 times, since that's what's getting multiplied. So 4 times 4 times 4 is 64. For the theta, we would just add theta plus theta plus theta. So 60 plus 60 plus 60 is 180. So again, you would see either your normal format, or again, we could just say cis format for this if we want to be a little lazy on our writing. All right, the last one, to find our r, again, we are raising this to the third power. So we're going to just multiply this by itself 3 times. So we get 8. And then for theta, you would add them up. So 270 plus 270 plus 270 is 810. Now again, you might not want to write that as 810 because that's pretty far outside of our 0 to 360 range. So we could also subtract 360 till we're back between 0 and 360. This is equivalent to 90 degrees. So we could write this as r times cosine of 90 plus I times the sine of 90. Or, of course, cis notation again works as well. All right. Thanks, everyone, for watching. We will work more with these in class.